Good morning. I hope you're doing well. I'm doing fairly well. As you may have guessed from the thumbnail of this video, the results of our testing over the last couple of weeks have not been quite what I was hoping for, but it's not all bad news. I actually feel kind of okay about it. Obviously, I would prefer if everything worked out perfectly, but, is what it is. But yes, we'll get there when we get there. As always, there's a couple of things I want to go through first. Some very fun things as well, actually. So maybe this is what's kind of putting me in a good mood now, is that I can actually present to you these fun things. But yeah, we'll get to the meat and potatoes in a little bit. Okay, so yes, leg measuring hasn't obviously helped, but we will get there. First, we have this week's fun tangential thought, which I think is a fun one. It's kind of similar to, I believe, last stream 2 weeks ago, when I think it was that one when I was talking about juggling the huge concrete spheres, and how I mentioned in that stream that I suspect that may not happen for me to be able to witness myself. It may not happen within my lifetime, and I think what I'm about to describe is even more in that direction. I think we're a while away from this, but it would be cool nonetheless. And this is the idea of juggling people. So not just juggling balls, but juggling people. And I have some cool videos to show you related to this. So here, I've got links for these videos in the description as well. They're called Fun with Juggling Lab. There's a couple of them. Actually, that's not the one I wanted to show first. This one. Oh my god. This one. So this is obviously a bit of a joke thing. They've got a ball juggling human characters. And so I was like, yeah, okay, there's nothing different between that and normal juggling. It's just that it's the ball juggling the people instead, or a big robot juggling people around instead. It's like, yeah, whatever, that's not that interesting. Where it does get interesting is when the people are also juggling themselves. So I believe in this, he doesn't have this clip up for very long, but I believe the people are all juggling to themselves individually. None of the balls are being transferred between the different people. However, I see no reason why that couldn't be the case. So there's balls moving between, there's people being juggled, and there's also balls being juggled by those people, between those people, and potentially to the hands that are juggling the people in the first place. So it's kind of like everything is looping into each other. And I've tried to follow this through, and I can't spot any instances where there is a ball being thrown between one little character and another one. I believe they're all just being self-contained. But yeah, I see no reason why they couldn't be both. Now, the reason why I say people being juggled in this is because I feel like making a robot do that would be fairly difficult, having the self-writing aspect, but also having a human do that would be extremely difficult. I definitely do not have the acrobatic abilities to do that myself, and I think that would require a tremendous amount of practice to do. But it would be pretty damn cool. I just generally strongly recommend checking out these videos, the Fun with Juggling Lab videos. If you want to get a rough idea of what I'm kind of thinking with regard to the patterns that can be created, these videos are a very good showcase of that. Obviously, some of these patterns are very not possible because there's a lot of self-collisions and whatever else, but some of the patterns are just amazing. Strongly recommend it. And yeah, there's links for both of those videos in the description. And there's 2 more as well. There's 4 Fun with Juggling Labs, and they're all quite good. Definitely recommend. EQ Poker says, picture to Warner Bros. Movie world. I do think that one of the biggest... ultimately, the only real commercial value, in my opinion, that Jugglebot has is for entertainment purposes. And I really do think that if this goes well, then these juggling robots would be more present in theme parks and that sort of thing. I actually know one of the juggling robots that I don't know, I wouldn't say it inspired this project, but it was interesting to watch when I was starting to just get a feel for what this project could be, was made by Disney Research. And if anyone's not familiar, Disney Research has some very, very cool videos on YouTube. I'll put a link in the description after this stream, but I believe their channel is called DisneyResearchHub, I think. For some reason, they don't allow comments on any of their videos, which is kind of weird, but their videos, they're so dry. They've got the worst narrators ever for them, but the content is very, very interesting. They're doing some very cool stuff over there. And yeah, so they made this juggling robot. It wasn't really like good, and which is presumably why never really went anywhere. It was very humanoid. It was very cool, and it could like throw between people. I think it was intended on being like a kind of interactive exhibit sort of thing. I do think that the human aspect of it was important for them because they're all about like animatronics and things looking cool. I don't know if this form factor of Jogglebot would be very appealing to them. I guess they could kind of like put it in a skin of some sort. But yeah, no, I fully expect these to be in like theme parks and that sort of thing, which is so cool. Iki Poker says, I'm wondering if a robot could juggle 3 cages with people in it as a ride. Like, what's that movie? Spy Kids. That would be... if you were in like one of those big orbs with like with sufficient padding, I think you'd be alright. You'd really get kind of tossed around. Although, we are yet to see how much the ball spins when these... I suspect that when Jugglebot is working properly, the ball actually probably won't spin very much, so maybe it could be a bit of a relaxed ride, potentially. Maybe not relaxed is... yeah. I think it'd be very, 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 very cool. But, yes, obviously not for some time. So, another cool, fun thing is that I couldn't help myself, and as I was alluding to last week, or last stream, about the Bambu H2D printer, I got one, and it is amazing. I'm such a fan. I bought it the day after the stream 2 weeks ago, and it arrived on the Tuesday after that, which was so quick. It's like I bought it on a Saturday and it arrived on Tuesday. Like they're ready to go to ship them out. It's so good. I am, such a big fan of it. I've got a few things to say about it, but I'll just go through the ones I've got on the slide first. The first thing is that there's one part on Jugglebot that was extremely difficult to print, other than the bellows, and I'll talk about the bellows in a sec. So this part on the leg, which for context is the part that the motor... there's a lot going on in here. So we've got carbon fiber tubes slide into these 3 slots. The motor is on a bracket that slides into like this kind of region in here. Carbon fiber tubes also slot into these 4 slots over here. And then there's a bunch of pulleys that sit inside. So there's a pulley in here, there's a pulley in here, there's a pulley in the middle in here, and in here. And yeah, so this sits on the leg at the top of the motor there. And yeah, this is very difficult to print. I tried to design it as best as I could to avoid needing supports, and it does print without support, so obviously this way up. But there are some regions that are very tricky. Like here, I did as much as I could to make that not an overhang, but it's pretty unavoidable given the rest of the geometry. And this has kind of been my benchy for comparing different prints. And I don't know. I had my first print fail on the H2D when I first tried this because the bottom, this is in PDJ, the bottom was warping up, which is interestingly something that I never really had happen on the Prusa printer, on my Mark 3S. But I'm pretty sure the reason why this failed was because I put it in like the worst spot possible on the print bed. And if anyone hasn't seen any of the videos or anything on the Bambu H2D, the way that the heat bed is heated is, I don't know, it seems like the only component of the printer that they really skimped out on. So if I show you here, this is like the bed, and I'll draw on this. The heating element, as far as I understand, goes kind of like this, and I think it loops back around in the end. But this, I think that this middle section doesn't even go that far over, so it's like this kind of thing. And I put this part right here. And so it's in like, I think CNC Kitchen had a video on this where like the heat here and the temperature here was like 10 degrees off. And because I put this part right on that kind of junction zone where there was not consistent heating, that it failed. Like it lifted up and failed. I literally, all I did to make it print properly, to get a full piece, was just move it on the print bed about 10 centimeters. That was it. Literally the same filament, like I started it as soon as this print failed, like straight away, only just moving it over. So if you do have a Bambu H2D, don't print in that area. Just avoid it if you can, and yeah, kind of stick to the other zones. But even then, I'm actually not It's not perfect. It's definitely nicer than the prints were on the Prusa, but there are some regions, like that one that I highlighted before, where there's that overhang. It's kind of hard to show on camera, but it's still not perfect. On the Prusa, I did need to go through for all of these that printed, and I had to like manually get in there and clean it up a bit so that it didn't rub on the pulleys. But like in here, for example, there's a bit of like surface issues, like there, which is interesting. I did also try slowing it down. I printed it at 50% speed, and it is significantly nicer, but there's still that kind of surface defect. However, this is with old filament that I did not dehydrate beforehand. I don't think PDJ is really that big of an issue with that, with being dehydrated, but I don't know. It's good, but it's not perfect. My only gripe with using this as as like a benchy test print is that it takes so long. It's like a 3-hour print, even with the H2D. And that's actually my next comment, which is that it is so fast. On the Prusa, this part takes 5 hours and 52 minutes. On the H2D, it takes 2 hours and 57, so pretty much exactly half the amount of time. And better yet, on the Prusa, I could only fit 3 of these parts on the bed at once, because it was just too big to be able to kind of tessellate more. But on this printer, I can fit 9, so I can just print all of the ones that I need, plus extras if I wanted to, just at the same time, press print, come back, 18 hours later, 20 hours later, and they'll all be done. So good. Maybe I'll avoid that region, so I'll print 8 or something, but yeah, it's so good. Just looking at comments. Stormy says a few minutes late. The DisneyResearchHub is, he says it's essentially personal research projects by the engineers designing things, which is why the narration is so dry or outright missing. Yeah, it's just a bunch of nerds making their own videos. That makes a lot of sense. I was always a bit confused by the structure of those videos. They're super, super dry, but they're so good. If you are interested in this project, you will definitely be interested in the stuff that they do, for sure. So, further Bambu excitement is that the bellows can print. Literally the first time I tried printing these, it just worked. I couldn't do it in vase mode because, I didn't try it in vase mode because I was doing vase mode on the old printer with a 0.6mm nozzle. The Bambu comes with 0.4mm nozzle stock, and I don't have any larger ones, and I think that 0.4mm in vase mode is going to be quite thin for this. I don't think that'll really work at all, like just thickness wise it'll be too weak. So this is not in vase mode, so there's this nice big seam down the side, which I don't really mind too much, but other than that, like, it is good. And I didn't dehydrate this filament beforehand, which is why you can kind of see it's a bit, I don't know, kind of gross on the surface, but it still worked. It just printed fine, and like it functions perfectly fine. It's actually more stiff than the other ones were. I think this is actually the strongest bellows that I've ever printed, and it was literally the first try. So I am very, very, very happy about that. It's so satisfying. Finally. I love being able to buy my way out of problems. Well, I love having the problems disappear as a result of, if I can buy it. It's just easier. There is one problem though, which is that because it's so heavy, I've got it on the same kind of like stand that I had my old printer on, but because it's so big and heavy and moves so fast, it really gets a bit of wobble going when it gets going. It shakes the whole thing around quite a lot. So I have printed off, but haven't installed yet, some brackets to attach it to the wall, which is another exciting thing that I love about this printer, is that I could never previously print things this big. I didn't really expect the larger print volume to be that big of an appeal to me. I was more interested in being able to print multiple materials at once, and the attendant like having supports and all that sort of stuff. But as soon as I picked this up, I was like, oh, wow, like this is large. This is actually like a real big object. I don't know. It's hard to describe, but I don't know. Something kind of switched in my brain. As soon as I touched this, I was like, this is different to what I was able to do before. And I'm very excited about this. It really opens up a lot. And I'm pretty sure you can actually go a little bit bigger than this as well, which is very cool. Like, this is just PLA, and like it's so strong, and I'm very impressed. And yes, in case it wasn't obvious, this is just to like attach the table that the printer is on. I'm just going to bolt it to the wall, and hopefully that stops the vibrations or the wobbling, because I really don't want that to collapse. That would be no good at all. There's the printer's just good. I've had a good time setting it up and everything. It has taken some time to get set up exactly the way that I want, but yeah, it's so good. Definitely recommend. If you're in the market for a printer, definitely at least check it out. It is a little bit expensive, but it's so good. All right. There's one more tangential thing, I believe, until we're getting into the meat and potatoes, which was another time-consuming thing that happened in the last 2 weeks, which is that I finally bit the bullet and committed to getting a good stock of bolts. So this is my one of my organization racks that I've got around the room. This one is the one that sits right in front of me. And this has all of my bolts in it. And this is what it looked like before, where I've got like M3, M4, M5. I don't really have very many M5 or M4 or like only one little selection of M2. But now I've got a pretty full stock of both M3, M4, M5, M6, and M2 bolts. So I should be good to build things of all scales now, which I'm very excited about. But of course, this took quite a long time to organize everything and to like get it all set up the way that I want. And I am very triggered by the fact that I don't have anything in this little spot. It's very, it took some time to like organize all of this to get it to be kind of together and nice. But I need some more M2 bolts to fill up my gap, which is a bit, yeah, frustrating. Okay, now let's get into the good stuff. Yep. So, after I've been talking with one of the tech rep people from Qualisys, which is the company that makes the motion capture cameras that I've got, and it's been very helpful to get some external opinions on things. So to give you a full recap, earlier I had a lot of markers on both the platform and the base of Jugglebot, and there were a couple of reasons for that, but I was also, at the time I didn't realize this was related, but I was also experiencing a lot of latency, a lot of lag, and like slow, reduced frame rate in the tracking of the cameras. So everything is set to be tracking at 300 frames per second, and I would like to be able to keep as close to that as possible. Like the faster the rate that I can get, the better. So, but I was only getting like 20 to I think like 40 or 60 frames per second or something, and I couldn't really figure out why that was happening. It was, if I would cover up the base, it would be faster for a bit, and then it wouldn't, and then if I cover up the platform, it'd be faster for a bit, and then it wouldn't, and it was all just a bit, yeah, confusing. It wasn't very consistent. But it turns out, if you have many markers set as a rigid body, then that makes the computation that the software for the motion capture cameras is doing significantly harder. So rather than fitting like 4 points to like match as closely as possible, I think I had like 20, I think it was on the order of 20 for the base, for both at least. It was over 10 definitely for each of them. And if there's that many markers, then it just makes it so much more computationally difficult to fit where that rigid body should actually be, so that there's like the minimum error. And yeah, turns out that scales very non-linearly, and the more markers you have, the slower things go. So my earlier intuition of more markers is better is definitely not correct, especially when not all of those markers are visible at all times, which is what I had. I had some markers that were actually visible none of the time, and that really didn't help. So it slowed things down a lot. So I'm finally getting the hang of things, and I have learned what makes, what you should do when tracking rigid bodies. And that is to just have as few as possible, as long as it's more than 3, because you need at least 3 rigid body. You need at least 3 markers to track the rigid body in 3D space. So I have now redone the base and platform markers once again. Now the base has 7 markers, which is potentially still too many, but I'll talk about what they are. Actually, I'll talk about what they are in just a sec. And the platform has 5 markers, but only 4 of them are ever active when I'm actually operating the platform. So let's talk about what these are. We have, yeah, I'll do this one. So on the base, the 7 markers that are on there, I actually haven't added the markers onto this model because I didn't realize that I hadn't done that yet. But they're all on this one, another new power hub thing. This one is 3D printed on the new Bambu. And earlier, just a very quick aside, the reason why I didn't 3D print this thing myself earlier is because I was worried about having supports under this whole top face, and I didn't want to have to deal with removing all of those supports on my old printer. Just as a quick little thing, I'll show you what the support removal process looked like when I printed it on this printer. Literally, all I did was lift up the corner of the print bed, and the part came off. Oh my god. The part came off, leaving the supports behind. I just lifted up the edge and then boop, off it came. And there's like a tiny, tiny bit of support left on the, I don't know, there's like a little bit of support left on this hole here, but other than that, it's all just left behind. And I was like, oh, this is different. This is not what I had before. It's so good. Yeah, so I've got a new one here. So the reason why I have 7 markers on the base is because I've got one in the center, and that marks the exact center of the base kind of like region. So if we go like a side view here, all of these ball joints on all of the legs are coplanar with this point here. This is directly in the center of all of those leg joints. So that sets the origin of the base rigid body. And then also on this piece, we have 4 other markers. We've got 2 that indicate which direction the y-axis is, and then 2 that indicate which direction the x-axis is. I could potentially change these around because I have noticed in QTM that not all of these markers are always visible at all times because there's that cable that runs up in the middle of Jugglebot that kind of blocks the markers sometimes. So I could potentially spread them out and move them around a bit more, but I like the ability to really clearly define the X and Y axes using these markers. And there's not really, I can't think of an easy way to do that with putting the markers somewhere else. I mean, I guess it looks like I do actually have some lined up. I don't know. I could potentially move them around, but I do. So that's 5 of the markers. To describe the last 2, I have just left 2. Right now, they're in fairly arbitrary places. There's one around approximately here. The other one is not really there. It's actually kind of around here somewhere. But they're basically just to increase the size of the like marker set that QTM is trying to match for. Because when I had it as only those central 5, even though there's no way to incorrectly fit those 5 if all 5 are visible, it's still sometimes, if it was not able to see one of them, it would still kind of flip it around and it would be inverted. And yeah, it didn't really fit very nicely. But I think having these other 2 on the like really far away from the rest of the 5 means that it's much more likely to fit it all correctly. And I haven't had any issues with it fitting incorrectly since I've added those 2. So it's possible. Maybe I should. I don't know why I didn't see this before, but I actually do have a line of, let me open up a new, let's get rid of the rest of the robot. Yeah, I don't know why I didn't see this before, but we actually do have a line of holes pre-drilled into the base along the y-axis, and we've got another line along the x-axis, so maybe I could actually just have the center marker on the on this part here, and then have one like out here, one over here for the x-axis, and then one maybe up here and up here for the y-axis potentially. I think that's probably a good idea, actually. I think I'll do that. Yep, that'll get rid of 2 other markers. Nice. Cool. All right, so then so on the platform, we have 5 markers, and 4 of them, I've gotten rid of all of the tape on the carbon fiber tubes. Previously, I had retroreflective tape around these sides of where the carbon fiber meets the printed parts. However, turns out it's not the best idea to do that because when you have tape wrapped around a cylinder, that makes a cylindrical reflective surface. And that means that if you only have a camera and you're viewing it, like a camera is only ever 2D, right? Like a single camera is only ever 2D. So that's only ever going to see a square or a rectangle shape rather than a circle. And these cameras, they're only, I have them set to only ever be looking for circles. So by having a rectangle there, it means that the circle is not really that well defined and can kind of move around a little bit. So the actual accuracy of tracking those rectangular sections would be worse than tracking a circular section. So what I've done is I've added these really small 6.5mm markers, and I've just super glued them onto these points on the platform. So we've got 2 on the sides, way out as far to the sides as I could possibly get, and then 1 on the very top and 1 on the side on the top. This one does get occluded by one of the cameras, but it is visible by 3 other cameras, so it should be visible all the time. And that has worked perfectly so far. I can't imagine that this can be incorrectly fitted, and I haven't had any issues with it so far. Granted, I've only had it like that for like 2 days, so we'll see. So those are the 4 that are active normally in actual operation. And then the 5th one is this one on here. And this one, similar to the one on the base, where this point is coplanar with the base joints, where the base connects to the legs. This marker up here is coplanar with the platform joints. So all of the joints on the platform are, in a plane with this point here. This is in the direct, perfect, should be, center of the platform. Now, in reality, that part is actually not that part. So that is this one here. I haven't actually swapped over to this one yet, more just because I haven't been bothered to. I'm not convinced. So I printed it this way up, and so the section that the marker is on was all supported, and it's good, but it's not perfect. There's a bit of... I'm skeptical that this is the exact size that it is supposed to be. And I actually measured that, so my old one was just a flat one. And with this one, I had to offset. This point here was not coplanar with the rest of the platform joints, but in QTM, you can just tell it, this point here should be, in this case, 13.3 millimeters above where the actual origin is. And putting this one on, and then offsetting the origin by 13.3 millimeters, and then putting this one on, this should be directly on where the origin is, but it was actually slightly off. And I don't know where the problem lies. It was less than a millimeter off, so it's not like that bad, but yeah, I'm not sure which one to use yet. But currently, everything is calibrated using this one and just using the offset to go down a bit. To be honest, I think both are probably fine. So I'm not going to really stress too much about it, but yeah. And then, of course, in actual operation, we can't have this marker here because the hand will smack into it. So this part is removed. And then even though that marker is not present in QTM, it is still, everything still tracks fine. So for example, we have QTM open here, and it's not Space Mouse compatible. I keep forgetting. And we can see there is the platform. So even though this marker in the middle is not here, so you can see like the light green ones are the ones that are actually being tracked. This one is not here, but we're still able to fit the rigid body because we still have 4 markers that are tracked, and we can figure out where they are. I also figured out recently how to display the 6-degree freedom data, which is very cool. So we can see the position and the orientation of both rigid bodies in real time. And you can actually plot them as well, which is kind of neat. You can like plot this in real time, which is very cool. Yeah, I don't know how to get them all to plot on the same plot, but I'm still learning how to use the software properly, but I'm slowly getting the hang of it. It's definitely very powerful. You may have also noticed that I added a similar setup on the hand here. So this marker here is it should be at the direct centroid of the ball when the ball is in the hand. And I haven't done anything with this yet, but I am anticipating using this for I can use it as like a further way of validating that the hand is where we think it is. So I should be able to get the hand to go like right the way down to the bottom, just make sure that it is where we think, get the whole hand to go the whole way to the top, make sure where it is where we think, and yeah, just as like a validation method. And interestingly, when I was creating this model to put this marker where the ball should be in the center, I actually realized that the ball doesn't rest in the hand where I thought it does. So I thought, like this section down here is circular, and I thought that the ball landed in the hand in that circular section. It was like the same radius. I tried to make sure that was the case when I modeled it, but it turns out it's actually not. It's actually a little bit smaller. So the ball is actually a little bit out of the hand when it comes down, which is interesting because we've been talking a bit about different hand designs, and one idea that keeps coming up is rather than having the hand be cupped at the bottom, we should actually potentially... Oh, I've gotten rid of it. We should potentially have a hole in the bottom of the hand, because the risk is that if the hand is cupped at the bottom, then the ball might come in, roll up that ramp, and then continue up. It's like on the other side of the hand and just like roll in, roll out. Whereas if there's a hole at the bottom, the hand will come in and just like hit a wall basically and just stop, and it can't continue up the other side. So this is kind of unintentionally doing that. I definitely didn't, and I didn't design this to do that, but it must be doing that to some capacity at least. I don't see how the ball could really easily roll up the other side of this. Yeah, which is maybe another way to achieve that whole effect, but maybe potentially make things more easily printable, for example. So, yeah, in any event, I found that interesting that it wasn't where I thought it was, which was a, I don't know, unexpected surprise. Yes. All right. So, look, comments. James says, label the empty box, spiders do not open. I'm not sure what box you're referring to. When was I talking about boxes? Oh, this one. That would be good, actually. Although it'd only really get me. No one else is really interacting with these drawers very much. Yeah. And Benjamin says, how strong are the actuators? That is a good question. I have a series of only really one YouTube video for these actuators. I've iterated on these actuators a bit, and I've got a video for each major iteration that I've had. So if you check out that video, you can see my results from the testing that I did then. The TLDR is that previously I was using Kevlar string to actuate the actuators, and that Kevlar string was by far the weakest point. That had a breaking strength of, I think it was rated for like 9 kilos, but as soon as I loaded the actuator up with 7 kilos, the strings were snapping. And yeah, that was the point of failure. I am now using, I've put it away somewhere else, ultra high molecular weight. Well, I'm using Dyneema string, which is also called ultra high molecular weight string. And that is significantly stronger. That has a breaking strength of like 110 kilos. And I haven't pushed the actuators to their limits since I've swapped to that string, because I only have 6 of these actuators and I don't really want to break any just for the purposes of testing, because they're working on the robot and I don't really want to stuff around with that. I am considering making another one, making a new full actuator with the Bambu printer to see how nice it can really get, because there's like all of this scraggliness. If I can get rid of all that and make like a real clean actuator, I think that'd be pretty nice. So I'm tentatively considering doing like retesting again and like seeing how strong it actually is, but it's definitely more than 7 kilos if you use strong string. How strong it actually is, I don't know. I have I don't really know what would break first, to be honest. It's all pretty solid, I think. But yeah, obviously something's going to break first. Okay. So now for the juicy stuff. Unfortunately, the leg measurements did not obviously help. Yes. So before doing any of the testing, I reset all of the O drives because I'd been mucking around with them a bit. Like I was only using one O drive to do all of this leg testing, and I changed which O drive that was throughout the testing. So I just figured I would just reset all of them by going through this process. You erase the configuration, restore it, reset the CAN ID because that's different for all of them, recalibrate the actuator, and then save. And that seemed to, get them all starting fresh again. I also did as John suggested, which was to mark physically on the actuators where the home position is and also where the approximate mid position is of all of the legs. And I don't know. So John's been suggesting this for the purposes of having an easy way to validate that the homing sequence has all worked properly and that the robot is where it should be. And I definitely understand that. And he suggested that this is done on like really big, expensive CNC machines. So you just have a little indicator mark, and the machine goes through its homing sequence. It then moves over somewhere else, like to where it's, I don't know, ready to go, like its resting position. And then you can visually, quickly discern if it's where it should be or not. Because if it's not where it should be, then you could have a big disaster on your hands. And I can definitely see the significance of that. But I'm skeptical how important or like relevant that will be for Jugglebot as it is right now, at least. I mean, obviously I haven't had these markers on the robot until now, but I have never had the impression that homing hasn't worked when I haven't noticed that it hasn't worked. Like if it didn't work, it's like very obvious that it didn't work because one of the legs is like still extended, for example, or like as soon as I start to move it, one of the legs just doesn't move because it hasn't been calibrated or whatever else. Like if something's wrong, it's usually very obvious that it's wrong in terms of like the homing sequence at least. But I fully appreciate that I don't really know very much about what I'm doing with regards to all this, so I did as John suggested because John has been something of a source of truth for a lot of the more complicated things in this project, and I figured I would. I'm starting to learn that when an aerospace engineer suggests you do something, it's probably a good idea to do that thing. So I've done it anyway, and yeah. So there's little marks on all the actuators now at both of those positions. So I should be able to see if something's wrong using those marks a little bit more easily. And yes, unfortunately, despite these 2 weeks of lots of calibration, lots of mucking around, the platform still does not go where we want. So I'll show you quickly. Yes, here is an example of the square. So this is still, this is only in like the upper right hand quadrant of the robot. And this is looking, I need to put my camera here, don't I? There we go. So this is looking down above on the robot, facing forwards. So like positive y-axis is forward. So like the ball would be like here, and yeah, like that's to the right. Yeah, up. It's yeah, face down, facing forwards. And yeah, we can see it's still not lining up. So to see what it looked like before, I did another round with the old mapping values. And so this is what it looked like before any of this calibration. This is what the square was. And we can see that the endpoint is, what is this? Like, 8 millimeters off in the y-axis. And it's pretty close in the x-axis for this point. But let's say 8 millimeters off. That's probably the furthest one away. I then changed the mapping values. And that led to the result that I was showing earlier, where it's still off, but in a very different way. So rather, like this point here was previously off in the y-axis, and now it's off in the x-axis. And again, similarly, it's pretty close in the y-axis. It's like 1.5 millimeters off. These are millimeters in the scales. Unfortunately, I don't know how to increase the font size on this, so apologies if you can't read it. But in the x-axis, we're like 6 millimeters off, so it's pretty much the same error. And this one's probably further again. Yeah, so it's not great. However, I realized after doing this, so when I ran that test, I had only changed the mapping values of how many millimeters does each actuator extend for each revolution of the motor. And that was one of the things that we calibrated. But there was a second thing that we calibrated, which is how long the actuator is after it's been homed. So for this test, I had forgotten that I had also calibrated the homing lengths. So this had only changed the mapping values. And I was thinking, okay, cool, maybe that's all right. Maybe if I set the homing values to be what they actually are, maybe we'll be good then. We were not. I actually don't have a run of just the square being run once, but I do have the square being run 10 times, which is another thing I want to talk about. And so this is after setting both the homed value and the mapping value. And we can see it's pretty close to what we just had, where there's still quite a bit of error. So we've got, 10 millimeters in both X and Y. So it's pretty far off. However, you'll notice something interesting here, which is that even though it's very far off of the target points, and actually this square is also it's like a full square around the center, so we're now going up to 100 100 100 negative 100 negative negative and then negative positive, rather than just staying in that upper quadrant. So now this is a bit more representative of like the entire workspace. But you'll notice that it is extremely repeatable. So something that's important to point out here is that I am only commanding the way that the robot is being commanded during this sequence is to, I'll move me over so I'm blocking less of the image. The way that I'm commanding this is where we're saying go to, say, this target point here at this corner. Once we have confirmed that the actuators are not moving anymore, then the platform is probably stationary, or it has to be stationary, and then we will take a snapshot reading of where we are with the mocap system, and we get this settled platform lengths, which for some reason doesn't like to save. Come on. So we get this, which is a nice, like, crisp. And then the red line is like the movements in between. So we're basically saying go straight for this point. Once we're there, we take a snapshot reading and then go straight to the next point. And so all of the actuators are being told from where you are right now, go to your final, go to your length at that next position, which is like 200 millimeters away. And all of the actuators independently just going straight to that target point. And that leads to this kind of like weird S bend that we see, because we're not actually commanding the actuators to do anything in particular during this middle sequence. They're just kind of going, they're independently going as fast as they can to their target pose, or to their target length, and that's it. And I am very glad, relieved, whatever, about happy to see how repeatable this is. So this is after 10 runs, and we can see even in, let me go back to this section here. This is probably the least constrained section. So this is in between, we are now, like 370 millimeters from point to point, with no intermediary commands in between. And it's still, within 4 millimeters of each pass over. And just to see how repeatable this actually truly is, I did a run with 100 iterations of the square, which takes a little while to load because it's a big file. And we can see it's still very, very repeatable, which is very nice. Let's get rid of the settled ones because it kind of gets in the way. But yeah, even here, this is probably the worst section, it looks like. And between 100 runs, we're going from, 74 and a bit up to 79 and a bit. So we're within 5 millimeters of every single pass from doing it 100 times. So I'm pretty happy about that. Of course, it would be great if it was that repeatable and also spot on the positions, but you know, it is what it is. One more thing I want to point out while we're on this view. Oop, what have I done? And actually, while I'm finding the next file, I'll note that there's a link in the description to a Google Drive folder with all of these recordings, if anyone wants to check them out. Let's just look at the single square. So something that's quite telling of the fact that the actuators are individually going to their target lengths without any regard for what the other actuators are doing is what is going on with the Z position. So if I get this one into here, once it loads, come on, in you go. What's going on? Let's get rid of that. Where's my data? Yeah, this is I don't know. Plot Juggler is being a bit funny. Huh? Oh, this was interesting. I wanted to show you this. All right, maybe let's try one more. Okay, yeah, here we go. All right, I'll make a new. Let me do this and do this. Okay, cool. This will work. So yeah, something that's quite telling about the fact that the actuators are moving with no regard for what the other actuators are doing is that we see these little bumps here. So this, again, on the top is the XY plot that we had before, and down the bottom, this is the Z position as measured by the motion capture system. And as I pan through this, if you've got a, I don't know, high enough resolution screen, you should be able to see little dots moving around on the upper plot. So like where we are here, there's a red dot here, and the blue dot is down here. So this is the commander position, this is where we are right now. And we can see when we are at the target positions, we're pretty flat. We're pretty consistently on 124.9-ish millimeters. But then as soon as we start to move, we go along, and then we have this giant peak. We move up by 6 millimeters while we're going through this weird S-bend thing. And then as soon as we get to the target position, we lock down again on 124.7 to 0.9 millimeters. And then when we move, we go up again, and then we go to the next point. So yeah, there's definitely weirdness going on where like one actuator might be a certain length at the current pose. When we command it to go to another pose, it might be the same length. So that one actuator says, I don't need to move. I'm where I am. I'm where I need to be. But then all of the other actuators need to move around it. And so it kind of raises or lowers I guess in this case, it always raises, but it moves the platform in a weird way as it's going between these poses. So yeah, just hold that in your mind for a bit, and we'll come back to this in a sec. So yes, I find this quite interesting in the way that it's moving around. Of course, this is not very unexpected because we're not telling the platform what to do in these middle positions, so there's no reason to expect that it should be going cleanly between the two positions. But there's something very interesting that I noticed when I was making the thumbnail for this video. So I noticed last time I had this sort of image in the thumbnail, I noted that I knew of no way to increase the line thickness of the plot juggler plots, of these plots. And I was a little bit bummed about that because I wanted to have this in my thumbnail, but it's a little bit hard to see when the thumbnail is really small. And I was like, this is kind of annoying. I want it to be bigger, but I didn't want to go around and trace everything because that would take some time. And I was a bit lazy. And so I just left it as like the thin line width. Today, I had a little bit more time and I thought, okay, to make this a bit more visible in the thumbnail, I will actually trace this with the little trace tool pen thing in Illustrator. And so that's what I did. I went around and I traced out the commanded path for this sad face. And then to make the actual moved path, I figured I'd save myself a bit of time and just copy the path that the commanded path, and then kind of like manipulate it however I need it. I figured it would be almost correct. Like it's approximately the same shape, and I would just have to do a little bit of adjustment to get it to be where I want it to be. And I was very surprised at how close it is when all you do is scale it. That's it. So here we've got the orange and the blue are pretty much superimposed. The blue is the commanded and the orange is the target. And all I did is if I move the commanded path down so that this bottom corner of the mouth lines up, and then just scale it, boop, 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 everything matches pretty much perfectly, which I find to be very, like, if that's a coincidence, that's a pretty strong coincidence. The only part that's off is this eye is just a little bit off, but everything else is pretty spot on. Like, I obviously didn't line it up super nicely, but that's pretty damn close. And I don't really know what to make of that, but it's interesting. There's some weird scaling thing that's happening here. So, yeah, I don't know. If someone just like happens to see what that means, I'd love to know, because I don't really know what this means. But it is what it is. Yeah, very odd. Yeah. And yes, it is very repeatable. So, yeah, there's one other very potentially related phenomenon that I'm observing, potentially related to this scaling issue, is that there is a discrepancy between the measured Z position and the commanded Z position. So I can show you, yeah, I'll show you what this looks like. We can see the robot in action. This will be the first time I've shown it moving around since we took it all apart. So this will be fun. So let's go to, yeah, let's go to this for now. We can boot it up. We can start the robot. And we don't need to home it because I homed it yesterday and I haven't needed to home it again today, which is very cool. Actually, if you want to see, No, it's not really going to work, is it? Ooh, no. Getting rid of that. But we can bring me back. So let's go... I'll put it into Space Mouse control mode. And then I'll show you my observations. So it lifts up, all nice and clean. And then we can go... For some reason, my display on the Jetson is really lagging behind. Like, I will see things in VNC before I see them on the monitor that is like HDMI connected to the computer. How is it faster over the Wi-Fi than it is over a HDMI cable? I don't understand. Alright, so we should be in Space Mouse control mode now, so I can move it around, and it moves the way you would expect. So while, let's just leave that sitting there. We can go over to QTM, and we can see, again, as I move the platform around, we can see that the platform moves around, which is very nice. And then we can also bring in this. This is some intense window management going on. All right. Let's move that aside. We don't really care about that too much. We do care about these readings. Again, I don't really know how to make this font bigger, so I will read it out. I apologize if anyone can't read it. So we've got the base and the platform, 6-degree freedom data. Now, if we read out where where we are commanding the platform to be, we can echo the leg lengths, let's say. Leg lengths topic. That is apparently not the topic. I swear it is. Oh, it's ROS2 topic. I forgot my command. Oh. Alright. So this is where we're commanding all the legs. Oh no, that's not what I want. Let me see what they are. ROS2 topic list. This is actually, while I'm getting this going, there's an interesting thing that I've been noticing when I have, if I've been away from the project for a little bit, especially certain aspects of the project, when I come back to them, it's always a bit of a ramping up process to kind of like refamiliarize myself with what I was doing last time I was working on it. And this code has definitely been like that this time, because it's been a couple of weeks since I've looked at any of this code, and now I've only had I was very busy with other unrelated stuff over the last 2 weeks. And I've only just come back to it in the last couple of days, and it's still it's taking a little while to refamiliarize myself with how I've set everything up, which really makes me not want to take a long break from the project. I think if I stopped for like a year, it would be very hard to get back into it. What do we want? We want platform pose topic, that's it. Platform pose topic. Come on. Yes, so we are commanding it right now to be at 170. And we can see as I move the Space Mouse around, that commanded position changes as well. But right now, its default position is 170 millimeters above the resting position at the very start. Now, in a separate window, let's also look at ROS2 topic echo platform pose mocap. So the measured position. And it's different. It's off by like 30 millimeters, 35 millimeters, which is weird. And so I only noticed that this was the case yesterday, and I don't really know why this is happening. And of course, as I move them around, they both update, and they're both off by the same amount as I move it around. So I don't really know what's causing this. There's a couple of thoughts I've got related to this. Let me shuttle this off so we don't have the fan noise. And I can go back to my normal window. Yep. Yeah, so I don't really know what is causing this problem. I can't help but realize or remember that when I adjusted the homed length of all of the actuators, they were all different by about 30 millimeters. For some reason, my earlier measurement, I actually don't know where that, I think it came from so the earlier measurement of where the actuator should be ultimately it came from the CAD model, essentially. The new measurements are the ones that I measured on the rig that I had set up a couple of weeks ago, and still do. It's actually behind me over there. So these new values should be more correct, and they were all off by around 30 millimeters. And I can't help but note that is basically the same amount that this offset is. So I'm not really sure. I don't know. I think I just need to look into it a bit more and see what I'm doing in my code. But a big takeaway that I am starting to realize more and more is that I'm going to make an effort to be much more thorough with my coordinate systems moving forward. And you will notice that I have defined in all of my headers for my pose commands, I am now actually filling in this frame, like the reference frame that we're using for this measurement. And I'm now calling this platform start frame. Because it's kind of hard to come up with a naming convention for this. There's like the global reference frame, which is Jugglerbot's base. Like Jugglerbot's, the XYZ that is on the base is like the global frame, and that's where all of the balls and everything will be measured with respect to, at least while there's only one robot. But the platform frame, I couldn't think of a good name for it because I don't want to be commanding the platform to move to like millimeter 600 in the Z direction if I was measuring it from the very base. I instead want to be measuring the platform position from the lowest position that it could be in. So what I've been calling platform start is the coordinate system where the platform is as low as it can possibly be. So like it's just homed, that's where that coordinate frame sits. And then when the platform is moving around, all of its measurements are with respect to that coordinate system, which of course then has an offset down to the base coordinate system. It should be same, like X and Y should be 0 in the base frame, and then the Z is whatever the height of the platform is once it's been homed. Yep. So I'm trying to be a bit more thorough with that, and that way we should be able to make use of, there's a bunch of like ROS tools that are designed and very efficient at converting between these coordinate systems so that you don't even need to do that math yourself. You can say, hey, I have this measurement in this coordinate frame. You, ROS, know how these coordinate frames relate to each other, and so you, ROS, can just do that conversion for me, and I don't need to do it. And that's not too complicated for what I'm doing because it's just offsetting in the Z direction, but I suspect that it will become more and more relevant as I introduce balls to the system as they're being tracked, and also as we add more robots. That's definitely going to become very important then to manage my coordinate systems properly so that the robots don't kind of think that they are each other or anything weird like that. I don't want my robots to have an identity crisis. That would be no good. Yeah, okay, so moving forward. Obviously, this is a bit problematic. Now, actually, one other thing that I would be remiss if I didn't mention, it's that we can't expect this system to be perfectly accurate. Like, we have that square, and we can't... It would be unreasonable, I think, to expect this square to be correct. I mean, objectively, it would be unreasonable to expect this to be correct within less than 0.1 millimeters because that's the precision of the motion capture system. So there is a hard limit on how close we can get. But even then, within 1 millimeter, it's like, it doesn't really matter. 1 millimeter difference for juggling is not going to make a huge difference, I think. We'll find out eventually. But yeah, there is a point where it becomes kind of like diminishing returns and we should move on to other things. John has been suggesting that limit for now for this sort of testing should be 1 to 2 centimeters. And I am starting to agree with that observation, with that suggestion, because we can just make the hand a little bit bigger. And if the ball is 1 to 2 centimeters away from the middle, it's still going to land in the hand. It might be a little bit offset, but it will just roll in and we can just continue. So yeah, especially with the sand filled balls, they are very good at kind of like finding the local minimum and just falling dead and losing their inertia. So I agree that 1 to 2 centimeters is probably close enough, which, to be honest, like, this kind of is. Like, we're within 6 millimeters on that corner. I of course need to do some more thorough testing with the entire workspace, but like, we're pretty close. We're within a centimeter. But we were also within a centimeter before doing all this testing, and I kind of want to be able to beat where we were at before all this testing. However, I am realizing that perhaps going through trying to make this system more precise by measuring it beforehand and getting a really good model of what the robot actually is, that may not be the right way to go with the system that I've got and with the tools that I have and all that sort of stuff. Instead, maybe we can be a bit more effective by using the motion capture system as a form of closed loop control. I don't really know why I didn't think of this before. I might have and just kind of dismissed it. I'm not really sure. I don't have any recollection of trying to go down this path in any serious way. But something about, I don't know, maybe just taking the break from things for a bit and like, I don't know what changed, but something I realized the other day, I was like, well, ultimately we are moving a thing around. We have like an actuator, or 6 in this case, but let's just say it's 1. We have an actuator and we have a way of measuring the output of that actuator, the motion capture cameras. So can't we use that measurement to inform the control of that actuator? And this is exactly what's going on with all 6 of the actuators individually. Like, we have an encoder on all of the motors, and the encoder tells us where we actually are, and we can compare that to where we should be, and then use that to control the actuator. This is obviously a lot more complicated because there's 6 degrees of freedom and 6 things that we can move around in order to affect the position of the platform. But ultimately, it's the same kind of idea. We're moving a thing, we're measuring the thing, and we can use that measurement to inform the movement. And so I'm kind of keen to give this a go, at least a very naive version. And my thinking of this general idea would be that we have a desired pose. So for example, we tell it to go to one of the corners of the square, and that's PD, D for desired. We have the measured pose, PM, M for measured. And so we can very easily figure out the error. So we say, yeah, we have 6 terms here, like XYZ position, and then I need to speak with ChatGPT, or if anyone here has any suggestions on how to do this, on how to compare the orientations, because you can't just subtract quaternions from each other. That's not how that works. Maybe roll pitch yaw is the way to go, I guess. I don't know. If anyone's got any suggestions on that, I'm all ears, but have some way to just like easily compare the orientations to each other. The position's obviously easy, just subtract the 2. But let's just say for the orientation, we use roll pitch yaw and we just subtract those values. And so we have this error. So we say that's how far off of the desired pose we actually are. Then for the next pose, we have a commanded position, which is the desired position of where we want it to be in the next time instant, minus some scaling factor of the error that we had on the last pose. And this is like the P part of like a PID control. I wrote this up like 15 minutes before the stream started, so I didn't have enough time to kind of like properly flesh it out. But the general idea is we can have a PID controller, maybe PD or just P, or just, maybe the full PID, who knows? Well, it'll take a bit of testing. But having that run dynamically, I feel like that should help with this, with tracking the position and getting it to go where we want it to go. I kind of feel like that should be much more effective than what we're currently doing. Of course, that would require a different way of commanding the actuators as well, or commanding the robot as well. We would probably get a very similar result if we just commanded the 4 points. I don't think that this system would work at all, like really well at all, for compensating for these errors that we're seeing in controlling the robot in this way. But if we changed it so that instead of just saying go to this corner, go to this corner, go to this corner, go to this corner, instead we discretize this path into like 100 or 1,000 points along the way, maybe not 1,000, but some number of points along the way, then as it's moving, it can adjust and compensate for how it has deviated from its commanded path. And I have high hopes for this. I feel like this should work. But I obviously haven't tried it yet, but yeah, I feel good about it. It does introduce some limitations, like we couldn't bring Juggerwatt outside, for example. We would need the motion capture cameras around to just operate the robot and get it to move where we want. But I am becoming a lot more okay with, I don't know, MVP, minimum viable product. You know, we can do all the fancy stuff later. We can get rid of all the cameras and all that stuff later on, once we can get the robot to actually move and to get it to actually go where we want it to go. I'm a lot more focused on like the matter at hand now, rather than trying to generalize to later things. Yep. Yeah, and I'm very keen to try this. I have very high hopes for it. And yeah, if anyone has any suggestions on how to potentially do this better, I am all ears. I'm aware that this can also be done with a Jacobian, where my understanding of how that would work is you say, okay, we have a measured pose here. We told the robot to go here, but instead we're actually over here. We can calculate the Jacobian for where we actually are, and then use that Jacobian to tell us how we need to move each individual actuator to get to where we need to go. But it feels like that would be more computation than the method that I like, the PID method that I just described, because we have to calculate the Jacobian and then use the Jacobian, which I guess is just matrix math. But the calculation part, like, that's multiple steps to get that, and you have to do that all the time. So I'm going to try this like PID approach to start with, see how well that works. Hopefully nothing breaks while I'm going through the tuning process. I'm definitely going to err on the side of being a bit more conservative and using a less scaling factor to start off with and just like ramping it up slowly. But yeah, if that doesn't work, then we can try the Jacobian approach and see what happens there. Yeah, lots of things going on, and yeah, it's coming along. Even though these results were not what I was hoping for, all hope is not lost, definitely. Yeah, we're getting there. We are getting there. Yep. There's one other thing that I wanted to mention, which is regarding, I believe I've spoken about this before in some capacity at least, but what may seem as my like flightiness with. Previously, I spoke about my flightiness with like specifically what project I'm working on at any given time, like with the ball butler and everything, and changing between different projects. I'm also aware of the fact that my rationalization for things has not always been the same. I'm very well aware of this. If you've noticed this too, good work. You've been paying attention. But I'm completely okay with this, because I think something that's important to understand about my relationship with this project is that I'm coming on 4 years working on this for probably at least, on average, definitely at least 20 hours a week, every single week for the last 4 years. And I am not convinced that it's possible to do something like that with the exact same like locked in focus the whole time. I don't think that's possible. If it is, then that's impressive for whoever can do that, but that's certainly not how I operate. I am very, very often changing my rationalization for things and the way that I'm thinking about these things. And I'm fully okay with that, and I think that part of the reason why I'm okay with that is because I know that as long as project progress is being made, it doesn't matter. Like, as long as stuff is happening in approximately the right direction, or like if you zoom out, it like could be in the right direction, I feel like that's fine. And yeah, I think that's a very important part of why I'm kind of still going with this. I think I would have stopped a long time ago if I tried to lock in on a certain rationalization and a certain way of thinking about it, and if that didn't work, which it never does, then the whole project would have been kaput. So yeah, I may seem a little bit flighty, but I am. But it's good flightiness. Well, productive, maybe not always. Somewhat productive. In the grand scheme of things, it's productive. Let's put it that way. Yep. Anyway, again, thank you for coming to my TED Talk. And yeah, I'm trying to look around to see if there's anything else to mention, but I don't think so. So yeah, thank you for listening. I hope you found it interesting. I forgot to check my calendar again, but I'm pretty sure there'll be a stream next week. And yeah, I hope you have a good one. Good luck with everything you're doing until next week, and I will see you then.